Good morning, everyone. Good morning to my computer science and engineering students. Today, I'm going to explain you about the topic linear search algorithm. Before that, I would like to introduce you to myself. My name is Shafaq Aziz. I'm an assistant professor in computer science and engineering department at Government Engineering College, Samastipur. So before moving to the main topic, I would like you to discuss about learning outcomes which you will be going to learn after completing this session. The first outcome is that you will be able to apply linear search algorithm for any real world problems, whether you are standing in a queue, whether you are working for any algorithm which uses the concept of linear search, you will be able to apply that this method there. Also, you would be able to analyze the time complexity of this linear search algorithm. So, before moving to the main topic, I would like to give you a prerequisite about a topic called array. Array, as you all people know about array, a bit discussion is like this that array is a linear data structure. So, array moves in a manner one after another. This means array is stored in the address form. If the address is 100, then the next element will be at 101. The second thing is it is a collection of similar types of data items. Means if you are making an array, it should all be of integer type or all be of in character type or all be of any float type. You cannot mix two data types with one another. The third and most important thing is that the elements which are stored should be of similar nature and has to be placed in a single variable at different locations. In order to study about linear search, we must have idea of array, how does it proceed and how does it works. So I would like to show the syntax of array, how it is represented. For example, it is data type of array name like int, and we have to mention the size that equals to the elements which we want to write. For example, if you want to write int a, then the size of the array that is 10, and in equal to you can write the under the braces all the elements. Now you can see a beautiful example below how array stores value, what are the index, and how it is stored in the memory. As you can see, the data type here is integer, consisting of all the numbers which are not having point values. The total number of elements here are 5, that is 12, 34, 68, 77, and 43. After that, you can see there is a memory address 1391, 1392, 1393, and so on. Each array element or value has an index starting from 0 ending up to 4. So an array begins from a starting index. By default, it is 0 value and it can end up to the number of elements minus 1. If you're considering it from 1, then it can goes to number of elements n. So these are the prerequisites which you must know before learning about linear search algorithm. Now, moving to the main topic, that is searching in an app. We need to search an element in an array with the position where it is stored. So basically, a search definition defines itself like that. If you want to find an element, you have to traverse the collection. If the element is found, then it is very good, or else the collection is exhausted. This means the element is not found there. So for this we use two kinds of algorithms. One is linear search and the other one is binary search. In this session, we'll be going to study a detailed description about linear search. Linear search, as the name suggests, it is a linear method or a sequential method. This means you need to search the elements one after another, stored in a sequential manner. Every element of the array is traversed and compared with the desired element which you have to find, and the result is given. So, linear, as the name is suggests, it is sequential. Remember this. The algorithm of linear search is quite simple. So, you have to begin as a step one that there will be zeroth index of the array, which you have seen an example of an array that the index begins from zero. Now, firstly, you have to identify the key value. The key value here refers to the element which you want to search in that particular array. Now, you will compare it with zeroth index of element. If the value matches with the key value, then the position is returned. If the value does not match with the key value, then we have to move to the next element. This step is repeated until the element position, which is equal to the key value, is not returned. If by traversing complete array you are unable to find any algorithm, any key value, then you can exit the algorithm directly and can say there is no element found in the complete array list. So now you can see an example which is very beautifully saying that how linear search works. So as you can see, these are the array samples where the index begins from 0, ends to 4. The elements here are 10, 15, 7, 2, and 8. The key element, this means which element you have to find or search, is 2. So at first step, we are comparing 2 to 10. Is it matching? As you can say, it is not matching. So we will say it is not matching and move on to the next element. Similarly, here we'll compare 2 to 15. As you can see, 2 is also not equal to 15. So we'll be moving to the next element, that is 7. Again, we'll compare 7 to 2 and we'll get the same result that it is not equal. Then we'll move to the fourth element at index 3, that is 2. Now, key element is 2 and the index element at in the third index element is also 2. So both elements are equal. Thus, we can say that element found at third index. So I hope you are very clear about linear search algorithm with this example. Moving forward, I would like to share the pseudo code, or I can say the code which you can use as for the purpose of coding. There will be a single for loop for all the elements in the item, or for all the elements in the array list. So if we have 5 elements in the array list, the for loop will continue from 0 to 4, that is n minus 1 or n times. If condition says that if the matched item is equals to key value, we'll get return the position, else we'll move to the next element. As you can see bottom, I have added a GIF also. Here we are scanning the element number 7. So from 1, 2, 3, 4, 5, 6, 7. Finally, we got 7 here. It is moving to 8, 9, and 10 for the purpose if there is any other 7 in the sequence or not. So linear search, whether you get the element at 2, it does not stop there. It will move to the end of the array. After analyzing this pseudocode, as you can see, the complete code runs for n times. So if the element which you have to find is at the end of the array list, then the complexity is order of n. And as you know, this case is called worst case. The second case is the best case if the element is found at the first position only. And the average case is that get the middle element at the middle position. So NY2. At that situation also the complexity remains at order of n. Now, advantages and disadvantages of both of our linear search. It is very simple and small. Again, you can say it works very well on unsorted arrow. It uses every memory efficiently, flexible, and if there is any insertion or deletion, it does not enhances the computation time. But it is very disadvantage for sorted data because the element will be at the end. And if the element will be at the end, this means it is a problem. Redundant comparisons. You have to repeatedly compare again and again if you're getting the elements in the first loop or second loop or third loop again and again. It definitely requires a proper termination condition or else it will be keep on going. And if the data set is large, then it is very inefficient to traverse each and every data set. For example, we'll be having a database of 10,000, then it will be traversing 10,000 times, and this will be very time taking and time consuming. So, at the end, summarizing the complete topic, I would like to remind you that now you are will be able to explain the complete working of linear search with various examples from real life, like how you can find a person eating in a queue or implementing any linear search algorithm based system like IRCTC queue system, or you can say operating system queues, or you can say FCFS or any scheduling methods also. Now, second, you can also analyze and differentiate between the worst, best, and average case of complexities of linear search. So that's all for today. Thank you so much for understanding this video. I hope you like it. Please like it and understand it. Thank you.